This is part 2 of a video on limits and graphs. In this part, we're going to consider some information given about a function, such as this information here, and we're going to try and put that together into a rough sketch of a function here. So the first thing to work on, sorry, let me get my pen right here. It probably is best to work one bullet point at a time. So this first bullet point, everything is talking about what's happening at x equals -2. And the first thing that we're told is that f of -2 equals -1. So we might as well put actually, let's start it the way it's probably best to do it in general. Let's start with the limit. This is telling us that the limit as x approaches -2 of the function is 3. That means as x approaches -2 along the x-axis, the height of the function gets closer and closer to 3. So we can start by putting a little dot there, an open circle actually, and whatever the function is doing, we know it's going to have to go up to that level and then leave that level. And then we'll figure out what else is happening. The information that f of -2 equals -1 tells us that at x equals -2, exactly at that point, the value of the function is -1. So to indicate that, we used a nice solid circle like this. So again, the open circle is suggesting that the graph, the height of the graph, the y value for this graph, is approaching the height of 3. But at x equals -2, the height is suddenly, it drops down to be -1, and then immediately after, it's back to the height of 3 or something like that. Let's move on to the next one. And what we're going to do is we're going to sketch a rough version of this, and then we'll start with a clean slate and see if we can make a nicer looking version of it. So for the rough version, now we look at what's happening as x approaches 1. So at and near x equals 1. What we're told is that as x approaches 1, the limit of f of x is 2. So again, that means that as we get closer to x equals 1, the height of the function is going to be closer and closer to 2. So we can make a nice open circle there, and we can make little tags to remind ourselves that the curve has to attach like that. We're also told that f of 1 equals 2, which means at x equals 1, the actual value of the function is also 2. That means we need a solid dot right there. What it really means, if we have an open circle that then is filled in with a closed circle or a solid circle, it means that the function, the curve, just looks like a curve going right through that point. We only draw the big circles to overemphasize what's happening. And for there, we don't really need to overemphasize it. So when we do a nicer version, we won't even draw a dot there. We'll just have the curve go through the right point. Now let's connect these. So there we go. And now we're on to the third piece of information, which is telling us about 3 things. We have first the function value, f of 2 equals 3. That's exactly what's happening at x equals 2. Then we have this here with x approaching 2, and there's a negative sign up after the 2. It's not before the 2, it's after the 2. So this isn't -2. This is 2, but we're approaching it from the negative side. So for x equals 2, there are 2 ways that x values can approach it. It can approach it from the left, or we can approach it from the right. When we approach from the left, sometimes we say it's from below, like thinking of going up in the x-axis is going in the positive direction, but going from x goes to 2 from the negative side is going to the left, like this. And what we're told is that when we approach from the left, the height of the function should be 3, or it should be approaching 3. So for now, let's draw a little an open circle at that point, and we're approaching it from the left. So let's connect our graph like that. It's going up to the point, the height 3, like that. Now we're also told that the limit as x goes to 2 with a plus sign after it, that means x is approaching 2, but from the positive side, which means from the right or from above, like that, like this little hand is doing. Isn't that hypnotic? You're like, no, Goldberg, it's not. So stop. Cool. So when x approaches 2 from the right, we're told the value should be 5. So let's put another open circle there, and we'll put a little tag coming off of it to the right side, to the positive side. And now the initial thing we were told was that f of 2 equals 3. That means exactly at x equals 2, we're going to have the value 3, which means we're going to actually fill in this first circle like that. The other one is an open circle. Remember that the vertical line test says that any vertical line we draw for the graph of a function, the vertical line can only touch the function exactly once or not at all. So right here, for instance, at -2, we're in the clear because this open circle, that is not part of the graph. That's a hole in the graph. So the only part of the graph that touches this line, x equals -2, is this one right here. Similarly, for x equals 2, this line doesn't touch the graph on the open circle, but on the closed circle, that's where it touches. So we're totally fine. Okay, so back to this. Now we're ready to move on to x approaching 5. So the limit as x approaches 5 of the function is 1, or the y value 1. So let's fill that in. The y value 1 is here, so we can use a nice open circle. And we know we're going to have to connect up, so let's do that. And maybe that's the last value, actually, so I'll just do something there. And we're told that f of 5 is undefined. That means that at x equals 5, there's going to be no value of the curve at all. So actually, we are done right now with our sketch. And all we have to do is fill it in. This last thing I should point out, f is continuous at all other values of x. This word continuous, we'll encounter that in a couple more sections, but what it means is the graph is connected. So the only places the graph might not be connected are at x equals -2, x equals 1, x equals 2, and x equals 5, and then the information here tells us whether they're connected. Notice that x equals 1, the curve was connected because the limit value was 2, and the function value was also 2. That's what it means for a curve to be connected. Anyway, let's move on to the next one. Here's a clean slate, and let's see if we can rapidly redo what we had. So the limit as x goes to -2 is 3, so that means we had an open circle here. We had a closed circle at f of -2 equals -1, so down here, like this. We had the graph can do whatever the heck it wants to do up until that point. F of 1 is 2, and also the limit as x goes to 1 is 2. So we just have to make sure that when we draw our graph, it goes through that point, like that. F of 2 is 3, so we have a nice closed dot here. The limit as x goes to 2 from the negative side is 3, so that means we're going to connect up. So our curve can do a little something like that. And x going to 2 from the right, the limit is 5. So that means up here we have an open circle. Then as x approaches 5, the limit is 1. So we're going to have down here something. So this could go like this. F of 5 is undefined, so that's an open circle. And then f is continuous at all other values of x. We said that means the graph is connected, so we can make it do whatever we want. So it could do that, for instance. So this is an example of a function which satisfies the first bullet point, the second, the third, the fourth, and the fifth. I hope this helps. Good luck.